Hi, this is Miss Gonzalez again. So what I want to talk about now is how we can model an exponential regression. So if you remember back to Unit 1, in the beginning of the year, we did a lot of this. We did this with all of the different types of regressions I could give you with linear, quadratic, and so forth. I would just want to recap to make sure we know how to do this since this is the exponential unit. Later, what we can do once we have all of this data is actually compare the different countries for the pandemic and probably come up with our own exponential regressions for the pandemic that's going on right now. But for now, what I want to start looking at is this data is an example of the US population. They're talking about the population from 1890 to 1980, and they want you to predict if it was to follow this trend, what would it be in the year 2000? Okay. So what I want you to think back to is what did we do back in the beginning of the year? How would I put this in the table? If you remember, if I was to put these years 1890, 1900, this is saying my X is starting 18,090 away, which would make this very hard to come up on a graph on the calculator and actually allow us to see the graph unless we would move our window out there. It also kind of skews our equation a little bit. So when you're talking about years and population, we usually like to call this year zero, correct? Hopefully you thought of that. If this is year zero, what does that make this value? Hopefully you answered A, because that would be our initial to that. So our A should be approximately 1890. We'll see what the scatter plot gives us in a little bit. And then you have the option to do two different things. You can realize this is going up by 10 and call this 10, 20, so forth. But we're going to go along with the book, and the book actually suggests for us to call this 1. So every 10 years is going up by 1. Okay, so I'm going to go to the next slide, which you will find this slide attached to the Nearpod assignment that is in Google Classroom. I gave you the PDF of this version so you can follow along or just refer back to it when you need. I don't need you to write anything down unless you just want to jot down your own personal notes. So here you can look how they're breaking it down for you. They're telling you to let 0 be 1890, let 1 be 1900, and so forth. Okay, so who remembers where these values would go? If this is 0, this is 1, this is 11, how do I put this in my calculator? Hopefully you are all thinking stat menu. Go to stat, and then hit edit. And all of L1 would be the year in terms of 0 through 11. All of L2 is exactly what we see here. No need to change it at all. Pause the video if you want to see this data. I'm not sure what's on our next screen. Okay, so some of you may have paused this so you could put it in. Great. Welcome back then. Now just take a look and make sure this is how your calculator looks. This would have been your stat and then hit edit. Okay, pause the video again if you still do not have your calculator set up. So now they talk about an appropriate window for your calculator. So this is an appropriate window that you're giving if you wanted to actually see the scatter plot. Remember, if you're trying to view the way the scatter plot looks like, you need to also hit second y equals on your calculator. Again, I wish I had the calculator screen, but I do not. So please let me know if I'm going too fast or if you have any questions about this. So the second y equals is your stat plot all the way up in that upper left-hand corner of your calculator. You want to make sure your stat plot 1 is on, because if it is not highlighted and it is not on, then it won't make the plots that you just put in your data. Next, you would hit second window for you to get your window. again, I wish I had a calculator to bring up. So they picked -1 to 11. That's just so you could see what's going on the left-hand side of your graph. And then they picked -50 again to see what's going down at the bottom of your graph, and then all the way up to 300 because that's as high as their numbers were going. They picked 50, but it's a calculator. It doesn't really matter if your scale is going up by 50 or not. Pause this screen if you wanted to make sure your window looked the same and to make sure your stat plot is on. All right, so now when you hit graph, this is how your scatter plot should look. If you are not getting the points, that means you missed that whole stat plot on. Please rewind the video to find out how to make sure your stat plot is on. So as you can see, this is slightly looking like exponential. One can argue this looks a little linear in a way, but because we're in the exponential unit, we are going to call it an exponential function. Okay, so now what you're going to do is you're going to select the stat button. Fortunately, this is just a picture of one, so I can't actually go in and do it, but I wanted to show you where it is. Once the stat menu comes up, you'll have the edit, which is where we put it. If you arrow to the right, you will see the calc. All right, and then you are going to go down. You'll see all of your regressions. You have your linear regression if you thought this was a linear trend. You have your quadratic if you thought it was the quadratic. You'll have quartic and so forth. We are in the exponential unit, so we are going to pick the exponential. As we get further into this unit, we might want the logarithmic or the natural log, the ln function that is also there. So remember that eventually, if we're talking about a curve that kind of looks like this, we'll probably be talking about a natural log function, and we'll want that type of exponential logarithmic function. For now, we want exponential function because our graph looks like it's following this trend. So go ahead and select that. Okay. Once you select that, the exponential regression, I don't remember what number that is. I think it was around 0. Please don't quote me on that. Just double check and find it on your screen. I don't have a TI-84 at home, so I can't look that up for you. So now, once you plug it in, this is around what you should have gotten, or at least what their calculator got based off of that data. Okay, so they're saying the growth is probably around 14%, 15% if you round up, because 1.15 is a 15% increase, and that they started around 67 for their starting value. Okay, so now if you were to go and have this equation, this would be the equation. As you can see, their plot was on. So if you got stuck on that part where you were trying to figure out what did I mean by the plot being on, this is how your screen should look if the plot was on. And now they are going to put this into the y equals to see if it is an accurate picture of the points. And hopefully, when you graph both the points and this equation, they line up pretty closely. And you could see, yes, the dots are pretty close. I bet you when you looked at that, your R was probably pretty close to 1, maybe like a 0.8, 0.9. That tells you how strong your regression is. Okay. Hopefully that worked. Again, at the end of this Nearpod slide, you will have a spot for questions. If you still were stuck on any of this, tonight's homework in Pearson will have to do with more of this modeling, so that will give you plenty of time to practice how to use your calculator. The last thing this PowerPoint slide talks about is talking about what happens when the year 2000, that is saying x is 11. So you would plug 11 into your equation for the x, and they get around 311.66 million. So the last thing for this slide, and if you could see it, it's not really what we were talking about. This is just an extension if you wanted to talk about it, is the logistics model. So this was talking about it. You could take a look and read it if you wanted to see it. This is a function for the logistics function. We're not testing on this year, so don't worry about it unless you're bored and you want to take a look at it. Is another type of example of equations that isn't typically gone over. But it doesn't hurt to take a look at it, see if you can answer these questions. That'll be your challenge for today. You could share that on the Flipgrid. I'll make a topic of answer the challenging questions and tell me how you did it if anybody's up for that challenge. Thank you.